Also in this chapter is when you basically learned that you had 3 arc formulas. You learned that you had 3 arc formulas. And some of you have started to notice that sometimes they're useful to use and other times it's quicker to use the unit circle, right? And so you have more than one way to get to the answer in a problem. Sometimes it's faster to use an arc formula, sometimes it's faster just to think about your unit circle, but what is the formula for arc cosine of x? Plus or minus inverse cosine of x plus 2 pi n or 360, but technically since I put x there, then you assume I'm in radians. Arc tan x is the second easiest one to remember because it's inverse tan x plus pi n. And the hardest one to work with is sine. Because, and it is also the very reason why when you got to chapter 6, you learned that there was something called what case? The ambiguous case, because sine is very ambiguous. Okay? If you had a 30-degree angle, you would know that you were in a quadrant where both 2 things were positive. If we asked our calculator, what is sine of 30 degrees? Our calculator will give us 1/2. If we ask our calculator, what's sine of 150? Our calculator will give us 1/2. But if we ask our calculator, what's inverse sine of 1/2? The only answer the calculator will ever give you is 30. Even though 150 is also an answer, your calculator does not know it. Why? Because your calculator knows the values in the principal branch. That's what your calculator knows. So when you get a 1/2, you don't know if you have an acute angle or an obtuse angle. And that's why sine creates an ambiguous case in triangles. On the other hand, cosine is not ambiguous at all because cosine of 60 degrees is 1/2, but cosine of 120 degrees is negative 1/2. So cosine always lets you know if you are looking at an angle that is acute or obtuse. And so that really does relate to why the arcsine formula is the most complicated one. It's the most complicated one because you have to figure out a way to go from quadrant 1 to quadrant 2. In geometry, what did you learn these 2 angles were? Supplementary. And these 2? Supplementary. And that's exactly why the arcsine formula, be with you in a sec, is inverse sine of x plus 2 pi n or pi minus inverse sine of x plus 2 pi n. There were 2 other things in this chapter. There was an idea called composition in this chapter, and we also taught you about basically the difference between y equals arc sine of x and y equals inverse sine of x. Composition. Let's say we asked you to find cotangent of inverse sine of 12/13. Now I know for some of you, you look at this and it looks really hard to you. And it looks like, what the heck is that? Okay? This should remind you of last year, f of g of 2. How did you do f of g of 2? You found g of 2 and f of the answer. How do you do this? You find out what inverse sine of 12/13 is, and you find cotangent of your answer. So that's why I say it's called composition. It's the same idea as f of g that you did last year. And the best thing to do to figure out a problem like this is to draw a triangle. So, draw a triangle. Choose an angle to be the angle you're talking about. And we want sine of this angle to be 12/13. So sine is what over what? Opposite over hypotenuse. So 12/13. Missing side? 5. That's right. 2 ways to find it. One is to know that triplet yourself. The other way is to use the Pythagorean theorem. Now, we want cotangent of this angle. Now, if you remember that expression of SOHCAHTOA, then we know tangent's opposite over adjacent. So what's cotangent? Adjacent over opposite. So here's the angle. What's adjacent? 5. What's opposite? 12. That's the answer. 5/12.